Hello, in this video I'm going to teach you how to represent a complex number in what's called modulus argument form, and this is literally just another way of representing a complex number. Now for this video you are going to need to know how to find the modulus and the argument of a complex number, and if you don't know how to do that I'll link my videos on that below. So as normal I'll timestamp the different parts of the video so you can skip through to the part that you want to see. But let's see where this comes from. So let's say we have a generic complex number z, which I could write as z equaling a plus bi. And let's say a and b are positive, just to make things easy. And let's represent it on this Argand diagram here, like this. So we could represent it like that. Okay, and I'll draw the vector of z onto. So this is my complex number z. Now for this example, let's just say this has a modulus, okay, of r. So this distance here is r. And I'll write it, the modulus of z is r. Let's also just say, to make it easy, that it has an argument of theta. Okay, so that's the angle between the positive real axis and the vector, and we'll call that theta, like this. So the arg of z is equal to theta. Okay. Now let's write down some more facts that we know. Okay, so the distance of this side here is going to be b, and this distance here, okay, along the real axis is a. So let's write down some facts using trigonometry. So I know that sine of theta, okay, well that's going to be equal to, let's write it down, so sine of theta is going to be equal to the opposite over the hypotenuse. So that's going to be b over r, okay? And we also know that if I take cos of theta, so cos of theta, that's going to be equal to the adjacent, which is a, over the hypotenuse, which is r. Now let's rearrange these by multiplying them both by r, okay? And we get that r sine of theta is equal to b, and r cos of theta is equal to a, okay? Now we can use this to represent our complex number. Remember, it's a plus bi, and we know that a is equal to r cosine theta, okay? So we could write that z, which is a plus bi, is equal to, well, r cos theta plus I multiplied by r sine theta. I multiplied by r sine theta. Now let's factorize out the r from both of the terms, and we get that our complex number z can be written as r multiplied by cosine theta plus I sine of theta. Okay, so that's pretty easy, and this here is what we call the modulus argument form of our complex number. So let's take a look at an example of finding this form for a complex number. So say we have the complex number 3 plus 2i, and we want to represent it in modulus argument form. So let's mark it onto our Argand diagram. So 3 plus 2i, the numbers on the axes are a bit weird, but that's this point here. So this is the point z. And let me draw the vector to that complex number like this. So the modulus of this complex number, well, I'll assume you know how to do it, but that's going to be the square root of 3 squared plus 2 squared, which is going to give me 13 root 13. So let's write that like this. Okay, and the argument, so arg of our complex number z, that's going to be given by the inverse tan of the opposite, which in this case is going to be 2, over the adjacent, which in this example is going to be 3. And if I work that out on my calculator, we get that it's 2 over 3, or inverse tan of 2 over 3, which is 0.588, like that. So now we've got the argument of z and we've got the modulus of z. Remember our formula, it's r multiplied by cosine of the argument, so theta, plus I sine of the argument, which is theta. And so that we can write z now as this. We could write it as root 13 multiplied by cosine of 0.588 plus I multiplied by sine of 0.588. And that would be the modulus argument form of that complex number. So hopefully this was useful. If it was, subscribe, like and share this video, and go over to my channel to watch all of my other maths tutorials. Thanks for watching.